us all drink water every day, multiple times a day. There's a recommended 8 ounces every so often throughout the day, but how often do we really get that? The question is this what we want to really be drinking? The majority of us are drinking something similar to this because of improper water purification. This is what we would prefer to be drinking, the nice clear water. So as we go through today, drinking water and the journey it takes, my name is Kristen Reihl, and today we're going to be speaking on the water purification and how it affects society today. Water is a basic necessity. All of us need it. It's required for all life. According to 2008's article of Science and Technology for water purification in the coming decades, approximately 1.2 million people lack access to safe drinking water. 2.6 billion have little or no sanitation, and millions die annually. What does this mean? Water is a basic need, and people will suffer and die without it. So as we go through today, we're going to discuss some of the areas that should be further examined, including the process of water purification, some of the pollutants that can be found in water, and how it's affecting society today. According to our textbook, Chemistry and Society, we read in section 5.11, water treatment, that water originally starts out in lakes, aquifers, or some kind of a reservoir, and then it's pumped into just a tank that chemicals are added into. These chemicals include aluminum sulfate and calcium hydroxide. The aluminum sulfate and calcium hydroxide will react with water and form what is known as a flock of aluminum hydroxide. And this flock will float to the bottom of the tank, and whenever the water settles, all the particles will move to the bottom and they'll get stuck in this flock. And then the water is pumped to another tank where they go through another set of filters, and there's charcoal or gravel, and then there's sand. And these will remove more impurities as we move on to the final step, which is the disinfecting step up here. And this step is the most important because this is whenever the water is disinfected and all of the living bacteria are removed. So during this, chlorine is added, and it will kill the bacteria by breaking apart all of the bonds. And some of the chlorine that can be added can include chlorine gas, sodium hypochlorite, or calcium hypochlorite, which we know many of these to be either Clorox or shock for our pools. And then this chlorine will be in the water. Some residual may be left over. Those of us that live in Alliance do understand the taste of the water is a little chlorine-y. That's all that really is. And in addition to some of the basic process, there are some more processes that are often used. According to 2008's article of Science and Technology for water purification in the coming decades, some of the additional processes can include reverse osmosis, which is depicted here with the semipermeable membrane, UV ultraviolet lights, which those will just break apart some of the chemicals or pollutants, and then ozone, which will, its toxicity will attack it. And this is discussed throughout both science and technology for water purification in the coming decades and in our textbook from section 5.11. So what the most important thing is to make sure that we're just removing these impurities so we don't get sick. And as we move further, we're going to go over some of the pollutants that can be found in the water. I mean, no one really wants to drink this. This is a little bit of a over-exaggeration, but some people are exposed to this in third world countries. So we know that some of the larger items can include trash, sticks, or basic dirt. But then according to 2008's article, Science and Technology for Water Purification in the Coming Decades, it was stated that widely distributed substances such as arsenic, heavy metals, halogenated aromatics, nitrates, phosphates, and so on are known to cause harm to humans and the environment. So all these pollutants are found in the water, and this is just the element side of it. There's a whole other living side to the contamination that can be found in water. Some of the living contaminants that can be found include cyanotoxins, which according to a review of cyanobacteria and cyanotoxin removal or inactivation in drinking water treatment, from 2010. They discussed the strain of bacteria known as cyanobacteria that creates these cyanotoxins that can be found in water. And if consumed, these will make us either very sick or could result in death. And just to reiterate, this is why we need chlorine to be used to break apart these living bacteria so we don't consume them. And I chose this just because you see this is untreated water, but sometimes the untreated water looks just like the filtered water. So we just have to be really careful what we're getting and where we're getting it from. So moving on, safe drinking water is required for all life, and many of us take access to our water for granted. You think that contamination in water only occurs in third world countries or those of lesser development, but unfortunately it happens in the United States as well. Last month, April 2015, Daniel Barker wrote in his article, "Utah City orders citizens to avoid drinking water after chemical contamination. What will you do in a water emergency?" That the whole city of Nibley City, Utah was required to drive to outside or neighboring towns to get their water sources to be able to drink because a chemical plant contaminated the whole city's water. And this went on for at least a week that they were without water. So looking at this from my perspective, I see just as a future teacher, I would really like to see the next generation understanding what pure water really means, and not only how is pure water made, but how lucky are we really to have the experience and opportunity to have the drinking water we currently have. Look at Nibley City, Utah. This can be a reality anywhere. So we need to learn from these events and take them to heart whenever moving on with our use towards treating water. So in conclusion, the general process of water purification involves many filters and chemicals such as chlorine or even other processes that we discussed, including reverse osmosis, UV rays, and ozonation. The ultimate goal is to remove the pollutants, and these pollutants can include elements or living bacteria so we don't get sick. We need to realize that the United States is very lucky, and there's more to the process of water purification than the average person thinks. These are my references.